All right, I'm live. Hey, everybody. I haven't done leetcode consistently since December 2024, and I've got a few interviews coming up. So I'm going to be sharing my screen today and go over NeetCode 150. As you guys can see, I've done a good number of problems in this problem set, but not the whole 150. And like I mentioned, this is my LeetCode profile. I've solved 610 problems. But for the entirety of 2025, I didn't do a single leak code problem consistently. Well, I did some leak code, but not consistently. And the last time I was really consistent was in 2024, from September until December 2024. So, 2025 here, I barely did any leak code. And then currently, only got back into it, 1, 2, 3, 4, 5 days ago. So, let's try and aim for at least 20 problems today. I will be live streaming until I finish. So let's get it. So the thing about studying for leak code after you haven't done it consistently in a while is we gotta do it pattern by pattern. So let's see what pattern do I want to go through. Um, do I want to do graphs? Do I want to do advanced graphs? Do I want to do greedy? Intervals, maybe. Let's just pick one. Let's pick graphs. Number of island is pretty easy. Let's do max area of island. Okay. So max area of island. I've done it before. Last time I did it was this year actually in January 2025, but let's see if I'm rusty or if I can still do it. Okay, I don't want that. Cool. Hopefully you guys can see my screen okay. Let me put this tab here so I can always see what I'm up to. Max area of island. Let's make this bigger. How about I just make this like the whole area? I think that's fine. Cool. All right, so max area of island, problem number 1 out of 20. Let's aim for 20, and then if we get there easily, I'll try and aim for 30. All right, max area of island. I'm gonna set a timer, max 10 minutes on this problem. Reset and start. Cool. So we are given a n by n binary matrix grid. An island is a group of ones representing land connected four directionally, horizontal or vertical only, so not diagonal. And we may assume all four edges of the grid are surrounded by water. Okay, that makes sense. The area of an island is the number of cells with a value 1 in the island. Cool, that makes sense. And we need to return the maximum area of that island, of an island in that grid. If there's no island at all, we need to return 0. So looking at this example here, this island at the very beginning has an area of 1. This island has an area of basically 1, 2, 3, 4. And our answer here is 6 is because we encountered this island 1, 2, 3, 4, 5, 6. And the reason why it's not connected to this island is because there's no diagonal connection. So, this is a pretty straightforward depth first search question where what we need to do is we just go through cell by cell in the island. Whenever we encounter a 1, we need to do a depth first search starting at that cell to identify the area of the island at that cell. So for example, if we encounter 1 here, we do a depth first search left, there's nothing, up is out of bounds, right is nothing, and we need to go down. I see there's a comment. Cool. From my sister. Anna, stop distracting me. Anyways, we need to go down, and then DFS down, the area is now 2, and then we go to the right. Yeah, so that's basically the solution. But before we solve any problem, we need to ask some clarifying questions. So the first question, the most obvious one, is it guaranteed a grid only contains one and zeros, one or zeros? Um, Grid, not null or empty. What else? What other clarifying questions? I think those are the clarifying questions that I have. And so, like I mentioned, the solution would be a depth first search solution. And the time complexity, it would be O of m times n, where m is the number of rows and n is the number of columns in the grid. And the space complexity in the worst case scenario is also O of m times n in the case where this entire given grid is an island. And so when we DFS, our recursion stack will contain the entire, every single cell in the island. So that's my solution. I am going to go ahead and just do some initialization here, grid, and then let's make m and n global. So int m, this is the number of rows. Int n, this is the number of columns. And we just got to initialize. So this grid equals to grid. This m is the number of columns, number of rows is equals to grid length. This n is equals to grid 0 length. And then we need to have our answer, which is the max area. So int max area is initially set to 0. Because in the case where there's no island, then we just return the max area. Max area is equal to 0. So like I mentioned, check every cell if encounter 1, DFS to find area of that island, and mark as visited to avoid revisiting duplicates. Cool. So for int I equals to 0, I is less than m, I plus plus, and then for int j is equals to 0, j is less than n, j plus plus. And what we need to do here is check. So get the current cell. So int current, or cc for current cell, is going to be equals to grid at ij. And once we know this, we only do a DFS if the current cell is a 1, which is part of an island. So if current cell is equal to 1, we can do a DFS on the current coordinate I and j. Okay. And this should be this dot grid, because to avoid revisiting duplicates, when we encounter 1 in our DFS, we will turn it into a 0. Cool. And then at the end, we just want to return our max area. So now I will be implementing the meat of the function, which is DFS. So private, would the return type be void? Let's see. I think the return type should be int, because we're trying to find the max area of that island. So private int DFS, it takes in a x and a y. And yeah, so the base case is for invalid cases, for when we go out of bounds, or when the island is not an island, so when it's a 0. So if x is less than 0, or x is greater than equals to the number of rows, so m, or y is less than 0, or y is greater than equals to n, or grid at index x, y is equals to 0, then we immediately return 0 as our area. Otherwise, what we need to do is basically, it's guaranteed now if the current cell is not 0, then it's 1. So we can do an int current area is equal to basically 1. And then we need to get the area from calling DFS on the neighbor. So before doing that, to make things easy, we need a direction array that contains directions to go to the four squares. So if we were here, it would go left, up, right, and down. So direction is a new int, and then it would contain 0, 1, 0, -1. This is going to the left. 0, 1 is going to the right. And then 1, 0, this is going down. And then -1, 0, this is going up. So yeah, this is direction. And then once we know the current area is at least 1, let's get the area of the surrounding cells. So what we can do is for int d in the direction array, we need to check the 4 surrounding cells by calling DFS. So we can do a current area plus equal to DFS calling, updating the coordinate of x to x plus d at index 0. And then the coordinate of y would be plus d at index 1. And then at the end, we simply return the current area. And before we return the current area, what we need to do is always find the max. So max area is max between the current max area and the current area that we found so far. And so at the end here, we can just return the max area. I'm just going to run this. We get a Stack Overflow error for some reason. So there's a bug here somewhere. We have grid. Oh, one thing I forgot is to set the current area as current cell as visited. So then what we can do is grid at index ij is now equals to 0. I think that's the only bug there. This should be X and Y. I am very rusty as I haven't done leetcode in a long time, but this seems to be working. And nice, we got a working solution with 30 seconds to go. Nice. 30 seconds out of 10 minutes. So that's 1 out of 20 questions down for today. So it's going to take me, what, 200 minutes? 3 hours? God damn, but it's fine. So max area of island is done. Let's do walls and gates. Walls and gates. This one is probably a tricky one because I haven't done it in a long time. Yep, haven't done it since September 2024, almost 2 years in. But let's restart our timer and let's go. We are given a n by n grid, rooms, initialized with 3 possible values. -1 is wall, 1 is a gate, 0 is a gate, infinity means an empty room. Okay. And we need to fill each empty room with the distance to its nearest gate. If it's impossible to reach a gate, it should be filled with infinity. So an empty room is infinity. And then we need to find each empty room with the distance to its nearest gate. And if it's impossible to reach a gate, that room should be left alone. So it should stay as infinity. Okay. So wall is -1, 0. So we're basically given this rooms grid. We have to find the nearest distance from infinity to 0 for every infinity. Okay. So some initial questions I have, it would be, value of rooms. So the values allowed in rooms, values guaranteed to be, the 3 given values. So we don't need to check for invalid inputs. Rooms, at least 1 cell size, no null or empty. And then there's no distance max than more than infinity. Those are the three clarifying questions I would ask. And then, it- what do I do now? Let's see. Um, yeah, so obviously, if we're trying to find the nearest distance, this seems to me like a BFS question, so a breadth first search question. And how about instead we search from every room? So the naive solution, we would do a breadth first search from every empty room, and then as soon as we encounter a gate, we fill that room, right? So in this one, say here, we know it's an empty room. We do a breadth first search, which can go to here, um, and then we can go to the right or go down, right? So if we go down here, the distance here is what, 2 versus here is 1, 2, 3, 4. So 1, 2, 3. This is 3. Okay, so we should return 3. Yep. -101. I don't understand this question. If it's impossible to reach a gate. Yeah, so this is just like the modified array. So this one here, it would be the distance would be 0. Why? Shouldn't it be 1? So I'm confused about the input and the output. Um, so this is obviously a empty room, right? And then the answer becomes 3 because we go 1, 2, 3. And so if this is an this is already a gate, so it's 0. That makes sense. And then here, shouldn't the answer just be 1? Yeah, okay, that makes sense. Yeah, okay. So I'm thinking, the naive solution, so solution 1 would be start a BFS at every empty room. So where the value is equals to infinity. Um, but the time complexity of this would be very inefficient. So time would be, in the worst case, every room is an empty room, right? So the time would be m times n empty rooms times, again, m times n cells for our BFS. So this would be very, very inefficient. Would be m squared times n squared, right? Space complexity would also be O of m times n. So this would be very inefficient. The solution 2 and the solution I'm leaning towards is, how about we start a BFS from every empty cell? I mean, from every gate. So for example, right? Initially, the distance would be 0, and the cells would be 0, 1, 2. So for this example 1, right? We would do a BFS at every gate, keeping track of current distance. So what I mean by that here is we know that um, the distance initially is at 0, and which cells has 0 distance to the gate? Well, it would be the cell where it's a gate, right? So for example, example 1 here, it would be 0, 1, 2. So 0, 2, and basically 0, 1, 2, 3 would be 3, 0 are gates. So 0 distance from gates, right? And then from here, we increment our distance by 1, right? 1, which cells are one cell away from the gates. So that is basically uh, cell 2, 0, and um, 0, 3, and 1, uh, 2. So these cells we can fill with distance as 1. Pretty straightforward. Um, so in this case, we can reduce the time and space complexity to simply O of m times n. Um, and it's more efficient. Because in the worst case scenario, we are keeping track of every single zero cell in our queue. So time and space, BFS at every gate using queue, keeping track of the current distance. And this would be my optimized solution right here. We have 2 minutes because I took some time to explain everything clearly, but let's get to work and make it happen. So I'm gonna initialize some variables here. So wall is equals to -1, int gate is equals to 0, int um, room is equals to integer max value. Okay. And what about a case um, we haven't encountered here? So if it's an obstacle, then we don't add it into our queue. It's basically an invalid. Yeah. So once we have this, let's just initialize everything. So let's get int m is rooms length. This is the number of rows. Int n is rooms 0 length. This is the number of columns. And the first step is initializing our queue of integer arrays. This is our coordinate of x and y. Call it BFS is a new linked list. And then search every gate and add to queue. BFS queue, right? So for int I equals to 0, I is less than m, I plus plus. For int j equals to 0, j is less than n, j plus plus. And to avoid storing duplicate values in our cell, we can have a visited set. So, okay, I know the time is up, but this is a very big problem that I gotta explain. So, uh, set of visited coordinates, or can I just do a 3D matrix? I don't think it matters, but Boolean visited is a new Boolean of m by n. Cool. Okay, so BFS, if the current cell, so int cc for current cell is going to be equal to rooms at index ij. If current cell is equal to a gate, then we want to add that coordinate to our BFS. Add new int ij. Okay. So then once we have added every gate to the queue, expand level by level. So the int current distance is equal to basically 0 initially because every gate is distance 0. Okay, so then what we do is while our BFS queue is not empty, while we haven't processed every single cell, what we need to do If it's impossible to reach a gate, it should be filled with infinity. Okay. Yeah, so while the BFS is empty, right? We need to get the size, so int level size, so size of this current level of BFS, aka the size of every cell that is this current distance away from an empty um, from a gate is equals to BFS size. Okay, so then for int I equals to 0, yep, I is less than level size I plus plus, and we need to pop um, every cell that is in this level size and set it to be this current distance here. So let's do an int current cell, or CC, is equals to BFS dot remove. And BFS is a queue, so it's guaranteed to be a first in, first out. So all the cells at this level, at this current level size that is at this distance, is guaranteed to be at the start of the queue. So what we can do is first add it to visited and then set the cell to the distance. So we can do a rooms, right? That's the name. Yep. Rooms at index current cell 0, current cell 1. I'm just going to say X and Y so we're more clear. Int Y is equal to X, and then Y is going to be equal to the current distance. So current distance. Um, yeah. So it's going to be equals to the current distance. And then we need to check neighbors. So check neighbors, and if valid, add to queue. And then we need to add the current cell to visited. So we have visited at index X, Y is going to be equals to true. Cool. And then after this, of course, we need to increment the current distance. So current distance plus plus. So are we returning something? No, it's void. So yeah, check the neighbors. So now for the neighbors, we need the distance array again. Int dir is a new int 0, 1, 0, -1, 1, 0, -1, 0. Cool. We have this direction array. We need to check the 4 directions. So for int d in direction visited, right? We can get a new x and a new y. So int new x is equals to x plus d 0. Int new y is equals to y plus d 0. Cool. So check for valid cell. So if basically mu x is less than 0, or mu x is greater than m, or mu y is less than 0, or mu y is greater than n, or we have already visited mu x, mu y, or if it's a obstacle, rooms at mu x, mu y is equal to, what did I say it as? A wall. Um, and just to be sure, or rooms at nu x, nu y doesn't equals to a room, then we don't want to add it, right? um, then we want to do a continue to skip. Otherwise, we can do a BFS add, basically a new int that has new x and then new y, just like that. And then we increment current distance. So let's do a run through here to catch any bugs. So we have m and n. Yep. Visited as a new Boolean array. And then we only add gates to BFS initially. And then we have the level size. Okay. And then we remove elements by elements. Get x and we get y. Set it to be the current distance. Set visited to be true. And then we need to check the neighbors. So ux, new y. If it's out of bounds, or we already visited, or it's a wall, or it's not a room, then we skip. Yep, this should work. Rooms x. Oh, this should be like small syntax error here. We get an out of bounds exception for length 4. This should be an equal, and this should be an equal. Okay, so the first one, for some reason, it's wrong. But the second one, it works. So there's a small bug somewhere here. Let's see. BFS is empty. Get the size. So what this is telling me is not adding the current distance, right? Let's see. Some print debugging. Plus has current size plus cells. Cool. This would be level size. Seems like it's 0 has 2 cells. That's correct. But then BFS is empty. Oh, this should be 1. Small bug there. Okay. One has 3 cells, which should be 1, 2, 3. That's correct. So we are off by 1. Why are we off by 1? 1, 2, 3. Okay, this should be level 1, level 2, level 3. How am I off by 1? Am I forgetting? If I do this, it would work? I don't think so, right? Why am I off by 1? Where am I off by 1 at? That's the question. All right, time for GPT. I'm going to use Gemini. It's more PG. This is for my brother. All right. Where's my bug TLDR? All right, let's see. Visited after you pull it out of the queue, but you don't mark it when you add it in. Because your neighbors aren't marked as visited immediately. Oh, I see. Okay, so as soon as I add it to BFS, right, I would need to set visited is also true. Um, okay. And that's because otherwise we're adding a bunch of duplicates. Cool. So that's the small bug there. Jesus Christ, this question is so complicated. How did I do it 2 years ago? Let's see. Yep. We have our BFS here, not empty. We get the size, current cell, yes. X and Y, yes. So I don't have a current distance. Oh, okay. I don't even keep track of the visited. So I only add empty. So I don't even need to keep track of the visited because the empties will be filtered out as long as I have, I see, that condition. Very interesting, man. Um, so let's try and clean this up because I don't even need visited. Okay. I don't even need the system out print. Remove, and then rooms XY is the current distance. So what I'm doing differently here is I'm processing it right in the inner for loop. But let's say I don't even keep track of visited, right? Because we don't need visited. If it's a wall, we add it. If it's not a room, which is infinity, does that mess up the logic? So how come this messes up the logic is what I don't understand. But anyways, we solved it. Let's see that this is not a TLDR. This is way too long. Right. I see. Yeah, okay. So we know that initially it's going to be a bunch of zeros. So only when we're able to add the parents, we want to do a basically a rooms at index mu x new y is equals to rooms at index the current x and the current y plus 1. So, wow, such a small fix, but it